Hello and welcome to yet another video of Cornerstones of Math, and welcome to yet another integral video related to ellipses. I have already covered this topic in my previous video, which I have provided the link to it in case you haven't watched it yet, but I realized that even that video didn't cover the most general case of the ellipses, so I decided to make this little follow-up video. Today we are going to deal with this ellipse right here, given by the equation 5x squared plus 2xy plus 5y squared minus 12x minus 12y minus 12 equals 0. This is a tilted ellipse as can be seen in the figure, and we want to calculate the area of the region enclosed by the upper part of the ellipse, x equals 1, x equals 3, and the x-axis. That is this shaded region right here. Also, this is the ellipse which is centered at 1, 1, but we don't really need that knowledge when calculating the area, so let's just move on. As you may all know, the area can be calculated by integrating the upper part of the ellipse from x equals 1 to x equals 3. So from this equation of the ellipse given in the implicit form, let's solve for y to obtain the upper part of the ellipse. So first, we rearrange in descending order of y. We can use quadratic formula to solve this for y, and actually, let's use the simpler version of the quadratic formula when x has even coefficient, because that will reduce the amount of calculation to some degree, which is more than welcome since we are about to deal with somewhat lengthy integral. So applying this formula, we obtain minus x minus 6, then we take the plus sign since we are dealing with the upper part of the ellipse. Then square root of x minus 6 squared minus 5 times 5x squared minus 12x minus 12, and divided by 5. If you expand and simplify all of these, you will obtain minus 24x squared plus 48x plus 96. Here, all of these numbers are multiples of 24, so we can take out square root of 24 to the front, which is equal to 2 times square root of 6. Then we have minus x squared plus 2x plus 4. And as for this part, we want to complete the square because we are going to use trigonometric substitution later on. Also, let us split the terms in order to make the integral look nicer. And completing the square process gives 5 minus x minus 1 squared inside the radical. So now we have to integrate this. Let's handle this polynomial part first, since these terms are easily integrable. So we have the antiderivative minus x squared over 10 plus 6 over 5 times x, then 2 square root of 6 over 5 times the integral of square root of 5 minus x minus 1 squared from 1 to 3. This part gives 8 over 5, so we have 8 over 5 plus 2 square root of 6 over 5 times integral of square root of 5 minus x minus 1 squared. And now let's use trigonometric substitution on the remaining integral part. Because we have 5 minus x minus 1 squared, we use the trigonometric substitution x minus 1 equals square root of 5 sine theta. This gives dx equals square root of 5 cosine theta d theta. Also, we have two endpoints 1 and 3, and we need corresponding theta values for those. Therefore, let us introduce theta 1 and theta 2 such that 1 minus 1 equals square root of 5 sine theta 1 and 3 minus 1 equals square root of 5 sine theta 2. This means that we have these values of sine theta 1 and sine theta 2. Also, we will need cosine values later, so let's also obtain them now. Here, notice that for our specific problem, theta 1 is equal to 0. Compared to more general cases, this will reduce the amount of calculation quite a bit. So with these set up, we have square root of 5 minus x minus 1 squared becomes square root of 5 minus 5 sine square theta, and dx becomes square root of 5 cosine theta d theta, and the interval of integration is now from theta 1 to theta 2. If we simplify this, we can obtain 8 over 5 plus, now just 2 square root of 6, and trigonometric functions are simplified to just cosine square theta. Also, let's use 0 for theta 1 from now on to obtain simpler expression in every step. In order to integrate cosine square theta, we use the half-angle formula for cosine to convert it into 1/2 plus 1/2 cosine 2 theta. Then we have the antiderivative theta over 2 plus 1 over 4 sine 2 theta, which gives the result 8 over 5 plus square root of 6 theta 2 plus square root of 6 over 2 sine 2 theta 2. Here, let us use double angle formula for sine to remove sine 2 theta 2, which gives 8 over 5 plus square root of 6 theta 2 plus square root of 6 sine theta 2 cosine theta 2. Here, let's use the previously obtained values of sine theta 2 and cosine theta 2. As for this theta 2 right here, it can be expressed using the inverse sine function. So we have 8 over 5 plus square root of 6 times inverse sine of 2 over square root of 5 here, and then square root of 6 times sine theta 2 equals 2 over square root of 5 and cosine theta 2 equals 1 over square root of 5. Therefore, in the end, we obtain 8 over 2 square root of 6 divided by 5 plus square root of 6 times inverse sine of 2 over square root of 5. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.